Hi, I'm Joe. I'm from the University of Bristol, and I'm going to be talking today about our study, Playing in the Sandbox. This work was done by my now former PhD student, Maysara Alhindi, and when I say this work was done by him, I should really not be here. He did all the work. I just supervised and edited his paper. Unfortunately, he can't be here because people keep blowing up his house. All credit goes to him. I am a poor substitute. If anyone is looking for a postdoc currently working out of Cairo, I know a guy, he's really good. So with that out of the way, I will try and answer questions as best I can. Sandboxing is great. Sandboxing is really fantastic. Given an arbitrary program, we can restrict what it does, right? Normally we think about this in terms of our mobile apps, where we're saying, are we comfortable with Facebook having access to all our photos? This talk is not about this form of sandboxing. Instead, it's about the form of sandboxing where we as a developer want to restrict our app's features just in case it gets compromised, just in case it gets hacked, so that it can't inflict harm upon our users. This talk is about this. Specifically, it's about Seccomp. Seccomp is the Linux kernel's kind of predominant sandboxing mechanism. It's been around for 20 years now. You get this weird assembly-like C syntax, and what it lets you do is it lets you inspect every system call that your program makes and write policies that decide whether to allow the system call to go ahead or not. So that's Seccomp. Specifically what we've done with this is we've gone and got some people who already know how to use Seccomp, who use it as part of their daily practice. As engineers, we've said, hey, we've got an application, can you sandbox it for us? And we've watched them do it and then done a bit of qualitative coding to figure out how they do it. We've asked them how they find Seccomp, what they struggle with, what they kind of like. And this is the program we've asked them to sandbox. It's not long, it just about fits on an entire slide if you squint a little bit. Surprising no one who's ever done a developer-centered study before, we found people struggled. We found that whilst most of our participants could create a working-ish sandbox, they all approached it differently. They all did it to varying degrees of success. Details are in the paper. If you're interested, go away and read it. I'm going to go over some of the more interesting things that we found. So we only recruited 7 people. We paid well over the odds for it. It turns out recruiting people who've got experience using low-level kernel sandboxing mechanisms is really hard. We spent about 6 months. We could only find 7 people who actually were willing to take part and had been doing this for a while. All of our participants, apart from participant 4, got something working, which is great. And better than yet, they all did it with allow listing, right? They did it with saying, these are the specific things that my program should be allowed to do, and everything else is banned, rather than going, no, I'm going to ban this, 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 and this. Again, participant 4 couldn't do this. They were having a really bad day. We said people could come to this study with whatever they wanted. They could use Google, they could use ChatGPT if they wanted. Participant 4 came with an app that they'd previously sandboxed, but they'd forgotten how it worked, and they just spent their time in the study getting really annoyed and frustrated and cross with it. So we're not going to talk about them much more. The way everyone did approach this task was, well, I mean, participant 2 had a look at the program first and started thinking, okay, well, this is what it's going to really want to be able to do. But then everyone started running things in Strace. Strace is the Linux system call tracer. It lets you see exactly what a program is asking the operating system to do. Participants 1, 3, and 6 went, oh, okay, I can see Strace is doing this, and this map to this bit of the program's code. I'm saying Strace like people have all seen it, but I appreciate we're not all developers here. This is what Strace output looks like. You'll note that it's slightly longer than the actual code for the program itself. Actually, most of this is irrelevant. It's not quite as bad as I've looked. You only really need that last little bit of it. The rest of it is just the program getting loaded and linked by the OS. But yeah, it's a lot of output. And participant 5 took one look at this and went, well, I'm not dealing with that. I'm going to feed this to the idiot robot. And so gave it to ChatGPT and said, look, you work out what to filter from this. I'm going to do this to save time. This is going to be much more efficient. They took the longest of all participants. They also ended up with an overprivileged sandbox because ChatGPT added some things. Participant 7 took the log and then added absolutely every system call that was made. Again, because that code contains the program linking and loading code, it meant their sandbox was again overprivileged because the first thing a program does is exec the program, and that's probably the thing you want to most restrict any arbitrary program doing. Again, they both ended up with overprivileged sandboxes. Participant 3 was really interesting. They had been used to using Seccomp to kind of harden programs on different architectures. So they came to the task with this kind of library they'd written. Library is perhaps a strong word, a header file, which abstracted away some of the details of Seccomp so they could just get on with writing this program and deal with the fact that on an ARM system, on a 32-bit system, you have a slightly different set of system calls, and it's a pain having to port things. They thought it would save some more time. Participants 2, 6, and 7, they went to a blog initially and said, look, I can't remember how to do this, I'm just going to Google it, and then got their answers from Stack Overflow. Participant 1 was kind of fun. They went and read the man pages. As a lecturer, I always tell my students to go away and read the manual, and none of them do it, but I had one participant who actually went to the manual and went and looked at how things were supposed to work, so that's a slow win for me, I suppose. This is all great, and what they managed to get working all kind of differed, and where exactly they put the sandboxing and when they did the decisions. It's all kind of fun, but for me the frustrating part is if we asked them why they were sandboxing any particular thing, they didn't know. They said, well, you know, I think I'm putting this system call filter in because it's something that fprintf needs, maybe. I'm not sure. I don't have an obvious clue. And when they were looking at the trace output, because we don't normally program using the operating system's low-level features, they really struggled with this. They said, well, okay, well, I can see this thing is calling this lseek system call, or there's this connect system call. Lseek's used to seek around in a file. I guess that's maybe part of fprintf, but I don't know. I've never heard of this connect thing because I'm used to using higher level interfaces, and they kind of didn't understand why they were sandboxing things, which is kind of funny. People, as they were doing this, assumed that, you know, accepted that it was hard to sandbox a program, and that for a small, tiny little toy program that we gave them, yeah, it's just about possible, but you know, there had to be a better way to do it if you were going to have a really large program. But they all did it this way. None of them did it a different way. None of them used something cleverer. None of them used an alternative method. This is what they just went with. And they all kind of liked this way of doing it. They all said, oh yeah, Seccomp's great, right? It's very easy to use, but couldn't figure out why they were doing things. Or, you know, you just have to be a better engineer to understand it, and once I've got the experience, then I'll be good enough for this thing. It's great. It's hard to use, it's overly complicated, but it isn't inconsistent. They were finding it frustrating, but believing that the fault lay with them for just not being experienced enough with this tool, which was kind of worrying to me as a usability person, right? I want people to be happy with their tools. So that's our study. What did we learn from all this? Well, back when Seccomp was merged with the Linux kernel, it was merged as part of the Chromium browser was pushing for it. It's used to sandbox most web browsers. There was kind of a lot of pushback from it, from the kernel people. Linus Torvalds said, you know, security is a morass. People come up with cool ideas every day and nobody actually uses them. Or if they use them, they're just a maintenance nightmare, and per system call permissions are very dubious. What system calls don't you want to succeed? That ioctl, you just made it impossible to do a modern graphical application. And, you know, there was a lot of pushback against these things, but I don't think that's entirely fair. The trouble with Seccomp isn't that you can't use it to create a great sandbox. You absolutely can. This is how we protect Firefox on Linux. The problem is that you can do absolutely anything with it, and very little of it gets abstracted. For some programs we can find in many operating systems, the code required to sandbox the application using Seccomp is longer than the functional logic of the application, which seems wacky. And as security engineers, what I really want, right, is we have design principles, we have standards, we have approaches that we use to secure things. What we've got with sandboxing at the moment is for a bunch of different operating systems, because Windows has a completely different sandboxing mechanism, as does FreeBSD, as does macOS, as does everything else. We've got a bunch of different systems that require you to use low-level, really operating system-specific features that don't necessarily make sense when looked at the programming languages you're using to write these things. Maybe this is something that we actually want to think about embedding into our programming languages and abstracting away, rather than doing at the operating system level for every single system. Maybe we need standard solutions. I will caveat this with I am an OpenBSD fanboy. Maybe they get it right. When we ask people what they wanted from a system, Well, they said, I just want to be able to say a couple of specific use cases and just have it sandbox for that. In OpenBSD, you've got a much less flexible sandbox. You've got Pledge, which just lets you limit yourself to a bunch of system calls. You can't inspect the arguments. Unveil hides away bits of the file system for you. But actually, that seems to map an awful lot better onto what users actually do. Well, developers as users actually want. We had a paper at an ICSI workshop last year where we looked at the extent different operating systems have been adopting sandboxing and the extent they've got their packages and their core operating system actually secured. And OpenBSD is miles ahead of this, perhaps because it is just 2 lines of code to sandbox things. So, I've gone a little bit quick, but that's fine. This is our paper. This is our study. All credit to Maysara. He's fab. Someone give him a job, please. Yeah, any questions?